Alright, so in this chapter 2.3 we're going to do polynomial and synthetic division, and this is a chapter I actually like quite a bit here, so I think it's going to be something that comes out clean a lot, and it helps us move through polynomials a lot faster than some of the tips we have, like looking on the graphing calculator, things like that. So first things up here are going to be long division. So we're going to have two different strategies to solve for division of polynomials. And the first one is long division. All right, so just like you did when you were in second grade doing long division, we're going to do the same steps, only this time we have polynomials. We've got exponents, we've got variables. So let's set this up. We're going to have x minus 2 going into 6x cubed minus 19x squared plus 16x minus 4. Okay? All right, so here's what we're going to do. We're going to take the leading term here, 6x cubed, and divide it by just the leading term out here. For right now, don't worry about the minus 2. So let's see, 6x cubed divided by x is 6x squared. I'm going to put it right here just to line up my x squared over the x squared. And now we'll multiply it back in to both terms, all right, like we're distributing. So 6x squared times x is 6x cubed. That makes sense. It should be the exact same thing. And then we have minus 18x squared. And so the next step here, sorry, I multiplied by 2, minus 12x squared. So the next step, we're going to subtract straight down. And be careful on this. When you minus a negative, you're actually going to add. So negative 19 plus 12 is going to be 7x squared. And just like from second grade when you were doing long division, you're going to bring down everything else. So plus 16x minus 4, and we're going to start all over. What's 7x squared divided by the leading term x? If you said 7x, you are correct. Let's distribute back in. So 7x times x is 7x squared. 7x times 2, negative 2, is negative 14x. Let's subtract straight down. So we're going to get that 7x's to cancel, and now we'll get 30x something went wrong. And what do we got here? Oh, forgot a negative up here. It should be a negative 7x here, so that's going to change this to a minus and a plus. And so let me just erase this. That's going to be a 2x minus 4. And so we'll start all over again. 2x divided by x is a positive 2. 2 times x is 2x. And 2 times negative 2 is minus 4. When we subtract this, we get 0. So it went in clean. And so we have 6x squared minus 7x plus 2. I'm going to rewrite this over here. X minus 2 was one of the factors. Now when we look at this, could we factor 6x squared minus 7x plus 2? All right, and so on this one, we can break it down. Let's see, 3 and 2. Let's see if it's going to go in here. We'll do a 1 and a 2. Yep, there we go. 2 times 3 is 6. 1 times 2. Nope, other way. 2 times 2 is 4. And 3 times 1 is 3. That'll get us to 7. In there, and they should both be negatives. And so now we have all three of our factors. 3x squared minus 2, 2x minus 1, and the original x minus 2. So this problem is completely factored. All right, so let's see if you can do long division of polynomials. Try exercise 11. All right, so once we've kind of figured out the long division, let's take a look at the division algorithm. Kind of a meaty section here, a lot of words going on, but the key in here is if you're dividing, and so let me bring back the last problem, was 6x cubed minus 19x squared plus 16x minus 4. All right, if that's our original, we call it a dividend, the number to be divided. Right, so that's here. And we figured out that when we divided this by the polynomial we plugged in was x minus 2. When we divided it by d of x, or x minus 2, we got as a quotient q of x. What was the answer that we got? We got 6x squared minus 7x, was it plus 2? Plus 2. All right, and our remainder here, r of x, what was left over? Nothing. Nothing was left over at all. All right, so just looking at this, these are the different pieces. You could rewrite it, but really the thing we're actually going to use is down here. All right, and so the answer to our problem before would be 6x squared minus 7x plus 2. And we didn't really care about the remainder because the remainder was 0, but what if there was some number? What we would do is we would say remainder over the original divisor, the thing we were dividing by. 0 over x minus 2. Didn't have to write that part because it was 0 on top, and so wouldn't really matter anyway. But if you do have a remainder, that's how you would write the fully complete answer when you divide all the way through using long division. Okay? All right, so let's move on here. Before we do this, one quick thing, and we're going to see this on both of the next examples. You need to write the dividend and the divisor in descending powers. So biggest exponent to little exponent. All right? So put them in the right order. And if you skip something, like you go 6x cubed and then you go to x, you're missing an x squared, make sure you put a 0 placeholder. And we'll see that in here in a second as well. Okay? So on this one, this is the one where we need a placeholder because we're going to say x cubed plus, there aren't any x squareds, but we need a placeholder just to hang on to them. There aren't any x's either, and then minus 1 divided by x minus 1. All right, so x cubed divided by x is x squared, and here's why we needed the placeholder, so that it could go right over the top of that. Multiply back in, and we'd end up with minus x squared. Subtract your negative, and we're going to get positive x squared, and bring down 0x. X squared divided by x is just 1x. And so when we multiply it back through, we get x squared, and we get minus x minus your negative, and you're going to get positive x, and bring down your minus 1, and x divided by x is just 1. You'll end up with x minus 1 here, and no remainder at all. And so x squared plus x plus 1 is what you should end up with when you divide x cubed minus 1 by x minus 1. All right? Your turn. Try 17. All right, we're going to try one more with long division before we get into synthetic division. And here's the example where things are not written in order, so we're going to have to rewrite this. So 4x cubed is our, oh, nope, I missed 2x to the 4th. 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2. And let's divide this thing by x squared plus 2x minus 3. So didn't have to have any placeholders, but did have to rewrite it in order. All right, so 2x to the 4th divided by x squared is 2x squared. Move all the way down here. And factor by all 3 parts now, all the way through. So we're going to get 2x to the 4th plus 4x cubed minus 6x squared. And nicely here, the x to the 4ths and the x cubes cancel, and we're left with just x squared. Let's bring down the rest. All right, so starting over, x squared divided by x squared is just plus 1. So here we're going to come back in, x squared plus 2x minus 3. And we'll subtract this down, and we're going to end up with x, and we're going to get plus 1 here. And at this point, x is smaller than x squared, so we're done dividing, but we do have a remainder. And so here's how we write our answer. 2x squared plus 1, and let's think back to the remainder theorem, plus, what's our remainder? X plus 1 over, what's our divisor? X squared plus 2x minus 3. And that's your full, complete answer. All right, so don't forget to put your remainder in if you have one. You're, I think, going to end up with a remainder on 23. Let's find out. Try that one. All right, so now we've got a nice shortcut if we have x minus k as our divisor. All right, so synthetic division would not work for this problem that we did for example 3 because we have 3 terms in our divisor, the part on the outside. It wouldn't work for 23 because it's x squared, but if we just have x minus some number as what we're dividing, we can go ahead and use synthetic division. And it's set up like this, okay? All the coefficients going all the way across, including zeros if you need them. K is on the outside. You're going to bring a down and multiply k times a, multiply on the diagonals, add down. Multiply the diagonals, add down your last numbers, the remainder. All right? And this also works for x plus k. Just remember that your number is going to be the opposite. Right? We've seen this for transformations, moving things sideways. So let's try this. X plus 3, so that's really x minus negative 3. So negative 3 is our number on the outside. Let's grab some coefficients. 1x to the 4th, 0x cubed, don't be tripped up there, need a placeholder. Minus 10, minus 2, positive 4, drop the 1. And here we begin. We're going to multiply diagonally. Negative 3 times 1 is negative 3. We're going to add down. Negative 3. Multiply. 9. Add down. Negative 1. Multiply. 3. Add down. Multiply. And we get negative 3. Add down. And we get 1. All right, so we can rewrite this as x cubed minus 3x squared minus x plus 1 plus 1 over, here's our remainder, x plus 3. All right, now where did this 3 come from? We divided by x, so x to the 4th is going to get dropped down to the 3rd, x squared, boom, drop it down to 1. There was a 0x squared in there. When you divide that, that ends up, I'm sorry, there was a 0x cubed in there. That got dropped down to 2. Right, so you're always going to just start with 1 degree less than what you started with on 4. All right, so first crack at synthetic division. Give it a shot on exercise 27. Okay, so let's take a look at the remainder theorem. The remainder theorem is very nice for finding y values if you know the x. Right, so you can plug, a lot of times we have situations where you have to plug in x to find y, right? I'm thinking of the vertexes that we just did. So on this one, if you have a remainder, that's the y value if you plugged in k. Okay, so let's take a look at kind of how that works here. So use the remainder theorem to evaluate the following function at x equals negative 2. If we do synthetic division, 3, 8, 5, negative 7. 3 drops, we get negative 6. We get 2, we get negative 4, we get 1, we get negative 2, and add straight down, we're going to get negative 9 on this one. Okay? If we do that all the way through, 9 is our remainder. Sorry, negative 9 is our remainder. What that means is that if you were to plug negative 2 back in, you get negative 9 as your y value. Okay, so you save the time of having to do 3 times negative 2 cubed plus 8 times negative 2 squared plus, right, all the way through. Instead of having to plug them in like that, you can use synthetic division, boom, to get your y value. All right, it's a great option if we have to find y values. So there's 4 options, plug them in, all right? Use synthetic division quickly, pull out what your y values are for the given x's. Problem 55. All right, so the factor theorem says that you have a factor if the remainder equals 0. All right? So this is really helpful for testing whether a 0 is a factor of an original problem, original polynomial. All right, so we're going to test to see if x minus 2 and x plus 3 are factors of this big original polynomial. All right, so let's do this. Synthetic 2, 7, negative 4, negative 27, negative 18, and 2 is what's on the outside, because remember it's x minus k, not with the negative. So 2 comes down, 4, 11, 22, 18. I'm going to go quickly. 36 minus 27 is 9, 18. Hey, look at that. There's no remainder. So x minus 2 does go in to that original polynomial. All right. Now here's the nice thing. We're going to take our new numbers, negative 3, and try to plug it into the new polynomial. 2, 11, 18. And 9. Let's do this. 2, negative 6, 5, negative 15, 3, negative 9. Hey, look at that. No remainder there either. And so what we've got here is we've just factored this big polynomial into x minus 2, x plus 3, 2x squared plus 5x plus 3. All right? And the last thing here is, can we factor this any further? So let's see if there's any way to split this up. It's got to be 2x and x. It's got to be 3 and 1. Can we make that get to 5? Sure we can. We do a 3 here and a 1 here. 2 times 1 is 2. 3 times 1 is 3. Put them together. We've got it. So look at that. We factored all the way down. Didn't have to use the quadratic formula. Didn't have to graph anything. We factored all the way. All right, so 67, something similar is going to happen. All right, and part E there says confirm your results by using a graphing utility. You're looking for all the places where your graph crosses the x-axis. That should match up with your factors. All right, so just a last reminder, this is the last slide here, no more problems. Uses of the remainder in the synthetic division, 3 different things. The remainder pulls out the y value, right? So if you plug in k, whatever the remainder is the y. If the remainder is 0, then x minus k is a factor of the original polynomial. And conversely, on that one, if r equals 0, then you do have an intercept at that point k. All right, so any questions on this, we'll go over it in class. Good luck with all the problems.